All right, my AB children, here we go. We're starting Unit 8. This is the last unit in our studies. However, there are, I think, like 12 sections. So it's been broken up into the first 6. So our next mastery check that's due the next Monday is for sections 8.1 to 8.6. So they start out with this average value of a function. That's a new topic to us. But this intermediate value theorem, the average rate of change, and the mean value theorem and this average value we're going to learn today are all topics that calculus kids tend to get mixed up with. So we're going to remind you of what these different things are. The intermediate value theorem, we abbreviate that IVT. The IVT says that you have to have a continuous function. So I'm just going to draw some kind of a function. Doesn't matter what it is. And I have a point A here and a point B here. That makes this coordinate, my function is f of x, f of A, and makes this coordinate f of B. And what this says, the IVT's intermediate value theorem says you have to have a continuous function It has to be continuous, and that all the values exist, I guess I should say y values, exist between A and B. I think when we talked about it in class, we talked about how, like, if you're a wrestler, go wrestling team, they've been doing great. If you're a wrestler and you have to lose weight or gain weight or whatever it might be, most times it's lose weight, right? You have to at some point hit every value of weight between where you're at and where you're trying to get to. So it's kind of that same type of philosophy that you've got to hit every y value between there. It's all continuous. If it's continuous, and again, it hinges on the fact that it's continuous, you're going to have y values for every point in between them because it's a continuous function. All right, so the second thing that we look at that sometimes gets confused with all this and the wording is the average rate of change. Well, that's the same thing as the slope. That's just the slope formula, average rate of change, slope. And then we learned something called the mean value theorem, the MVT, and that said that the slope has to equal the derivative of some constant in that frame between A and B. So again, if you've got A and B, somewhere in between here there's a C, and the derivative of that has to equal whatever the slope is of f of B minus f of A over B minus A. And then we come to today's topic, the average value of a function. The average value of a function on an interval from A to B, they didn't write the formula in here, but here's what it is. 1 over B minus A times the integral going from A to B of your function, f of x dx. Now, they couldn't talk about this yet because you didn't know integrals back in the day. You didn't know integrals when you learned the immediate value theorem or the average rate of change or the mean value theorem. So now we're adding in this average value, and it's all about the verbiage. Got to watch what they're asking for. The ones that typically get confused are the average rate of change versus the average value. Those two are ones that technically people confuse those two. And also the intermediate value theorem with the mean value theorem. So just be careful. I'm just kind of reminding you to give you a heads up. So let's try some problems. Find the average value. Look at the verbiage. Average value. Okay, I got to use this guy. And so what we're going to do is figure out, and that means what's the average y value on this function going between -1 and 3. So if I think of -1, here's -1. I'll give you some graphic idea of this before we get into the how to actually find it. If I look at f of -1, I'm here, right? If I look at f of 3, I'm over here. Where is the average y value between them? Where do you think it might be? What is the average y value between these 2 points? That's what you're looking for. That's what this average value is talking about. So let's see if we can calculate it. It says 1 over B minus A. Well, B is 3. A is -1 times the integral of my function 6 minus x squared going between -1 and 3. That's the average value formula. So now I'm going to see if I can work my way through this. 3 minus a -1 is 1/4. If I'm taking the integral of a 6 minus x squared, that would be 6x minus x cubed over 3, right? You integrate it, going between 3 and 1. They didn't give you a whole lot of room for this, did they? So I am going to put a 1/4 on the outside. I am going to put a 3 in here. That gives me 18 minus 3 cubed is 27. 27 divided by 3 is 9. And then I'm going to put a 1 in, so I get 6 minus 1/3. And for the sake of lovely time and long videos, this comes out to be 11/3. 11/3. Well, 11/3, isn't that like, let's see, that would be 3 goes into that 3 times with 2 left over. 3 2/3. Where is the y value 3 2/3? Let me change my color. 3 2/3 would put it right about here. Now, if I were to stretch this out, does that look like that would be the middle, the average value? If I were to take this and stretch it into a long piece, that kind of looks like that might be right in the middle, like an average would be, right? So when does the function, what's the function? 6 minus x squared, assume means equal, the value 11/3. When does the function assume this value? So when does it equal that? And so that's what you're looking for this second part of this question. That's going to mean that I'm going to take 6 3rds is 18/3. So now I have negative x squared equals 11/3 minus 18/3, or x squared equals 7/3, right? If I take that, subtract them, take away the negatives, there it is. Go to my handy dandy calculator because I don't know, square root, I square root this, the square root of 7/3. Now that would be plus or minus, this is giving you the x value, plus or minus 1.527, again coming from the calculator. Right, take the square root of that. I guess I should put plus or minuses over there too. Can I eliminate one of them? And you say, yeah, we're looking at positive, we're over here in the positive region, right? So this one is just x equals 1.527. So when x is 1.52, and it looks exactly like where we're at with our point here, then y is 11/3. And that's where that value would be, the average value. All right, so there's the first example, since the second one's not in that interval. Again, if I'm looking at this, you could also just go back to the interval. My interval only went between -1 and 3, and -1.5 would be to the left of that, so it's out of the interval. Now, second set, they're trying to help you with the verbiage here, comparing the average rate of change and the average value of a function. Which one are you looking for? Depends on the wording. So let's see. I have an h of t function, height is in feet, time is in seconds. What's the average height during the first 3 seconds? So average height would be like the average y value, right? This was the average y value. We want the average height. This one's going to be our new formula for the day. This one is 1 over in the first 3 seconds. That means 0 to 3. So 3 minus 0. Integral going from 0 to 3 of my function. Now, Mr. AP allows you just to call this, if it's already identified as h of t, you can call it h of t. So you don't have to write the whole thing out. But then I need to integrate it. So 1 over 3 minus 0 is 1/3. I have the integral going from, let's see, if I take the integral of negative 16t squared, that's going to be negative 16t cubed over 3. And then I have plus 41t squared over 2. I'm just integrating each of these pieces, plus 10t. going between 0 and 3. All right, then you go to your handy-dandy calculator, and you're going to figure out what f of b minus f of a is. So you're going to, there's lots of different ways that you can do this. You can even go just to the integral thing and have it integrate on your calculator. You know several different ways to be able to integrate on your calculator. The thing that most kids forget after they integrate is to multiply by that number that's in front. Don't forget that you've got a 1/3. So you're only integrating the h of t functions going between 0 and 3, but then you need to multiply it by 1/3. So don't forget that extra piece there. If you do that in your calculator, you get a value that's about 23.5 feet. Our units are feet. What's the average height? 23.5 feet. What is the average velocity? Now, isn't velocity already a rate of change, right? Velocity is a rate of change. And so if that's the case, then this time what you're looking for is h of 3 minus h of 0 over 3 minus 0. This one now is a little bit different because it's the rate of the rate. And if I'm the rate of the rate, then I'm looking at the slope there. So I find f of 3, which is -2. I mean h of 3. I'm sorry, that's not true. I plug in h of 3 into my function here. H of 0 is going to be 10, and then over 3 minus 0, and again, for the sake of time, this comes out to be -7 feet per second. So be careful if it's the rate of the rate, you're kind of going backwards and looking for what that slope would be. Number 3 changes it up. Number 3, I've got this guy, r of x is the sine of 2 sine of x minus 1. R is the rate. Again, they're giving you the rate of Mr. Bruce's waistline is changing inches per month, and x is in times per month. So what is the average rate of change that Mr. Bruce's waistline changes from the 10th to the 12th month? So this guy is the average rate of change again. Looking at this, r is already a rate. And since r is already a rate, this time you're looking for the average value. So here I go. 1 over 10th month to the 12th month. So that's going to be 12 minus 10. Integral 10 to 12 of r of x dx. And so I go to my calculator. I've got 1 over 2, 1/2 times the integral from 10 to 12 of r of x dx. Totally calculator. Toss it in the calc. And when I toss it in the calc, I get out a value of -2.683. And that is inches per month. He's losing lots of inches. I like that. And by the way, if this is confusing to you, maybe the curriculum video might explain it a little bit better. So don't hesitate to go and listen to that portion, at least, of the curriculum video. What is the average change of this rate during the first 5 months? Average change. That's like the slope then. So now I'm looking at r of 5 minus r of 0 over 5 minus 0. And again, I can go to the calculator and calculate out what those values are. If I put, especially if I put r into my y equals, and then I can go to the table and grab these values real quick, I end up with -0.383, and that would be inches per month squared. So that's the average change. So there's our first page. Let's see where we're going to go next. I think that's it for examples. So we're going to look at, again, if this is confusing to you, see if the curriculum video makes a better explanation of it. It is goofy when you're looking at the rate and trying to take another rate and how you go about doing that. So be careful on those moves. Let's try number 2. It's the first one I chose. Number 2 says, I chose it because it's the trig function of the first 4. So find the average value of each function on the given interval. Average value is the one for today. That would be 1 over pi minus 0 times the integral from 0 to pi of the function sine of x dx. 1 minus b over a times the integral going from a to b of the function. And so I know that 1 over pi minus 0 is 1 over pi. The integral of sine is negative cosine going between 0 and pi. And so that's what I do. I've calculated out here. 1 over pi. I need the negative cosine of pi minus a negative cosine of 0, so plus cosine of 0. Think of the unit circle. If I go to pi, I'm at negative 1, 0. Cosine is the x value, so this would be a negative, negative 1. If I'm at 0, the cosine, the point is 1, 0, so that would be a 1. And if I have 1 plus 1, negative, negative, 1 plus 1, that's 2, times 1 over pi gives me 2 over pi. And that's the answer. Done. Okay, so there's an average value. Next one I picked is number 6, and number 6 says, on the interval, find the x value where the function, this is important, the function is equal to the average value. So what I'm going to do is figure out the average value, right? So I've got to figure out the average value using our formula for the day, 1 over 3 minus 0 times the integral from 0 to 3 of negative x squared over 2 dx. In other words, 1 over 3. I'm going to clean this up before I actually take the integral. Negative 1/2 x squared. And I'm going to clean it up one more time because I can pull that negative 1/2 out. So I've got negative 1/6. Negative 1/6 the integral of x squared. So that when I get to finally taking that integral, it's really not that bad. So I'm going to take negative 1/6, and I am integrating x squared, x cubed over 3, going from, I didn't put my froms, 0 to 3, 0 to 3, 0 to 3. All right, so let's do it. So I'm still working on the average value. I'm not even done the problem. I'm just still working on figuring out this average value. So if I put a 3 in here, I have negative 1/6, and 3 is going to be 27 over 3, that's 9. If I put a 0 in, I get 0 over 3, that's 0. And so if I take negative 1/6 and I multiply it by 9, I get negative 9 over 6, or negative 3/2. That's my average value. The question wants to know, when is it equal to the function? So here I go. Negative 3 over 2, my average value, has to equal the function negative x squared over 2. There's a couple different ways we can go with this guy, but if I look at it, they both have negatives, so I can ignore the negatives. And I want to know if I'm big on cross multiplying, you all know that. Some of you can be intuitive and just find the answer automatically, but anyway, I'll show you the algebraic form of it. 3 times 2 is 6, equals 2x squared. Divide by 2, 3 equals x squared. Take the square root. Technically it's plus or minus the square root of 3, but you have an interval, and the interval is only between 0 and 3, so you know it has to be the positive guy only, and that's your answer. Done. Okay? That's when it equals the function. Now I'm making a big deal out of that because one of the questions we're going to come up to in just a second actually is similar, but you've got to set it equal to something else. All right, that was number 6. Next one is number 9. By the way, 7 and 8, find the average rate of change. That's the slope guy, f of b minus f of a. That's why I'm skipping them. You can do them. Number 9 is next on my list. And this one is one where it says, where is the instantaneous rate of change, the derivative, equal to the average rate of change, which is the mean value theorem. So when does the instantaneous rate of change? Well, that would be y prime. Let's see what y prime is. 2x minus 4. Right? Take the derivative. When does the derivative equal the average rate of change? Well, average rate of change is f of b minus f of a. So I've got to figure out what f of 4 minus f of 0 over 4 minus 0 is, and then I'm going to set those two things equal to one another. That's what it's asking me to do. Instantaneous rate of change, average rate of change. If I plug a 4 into this crazy thing, 4 squared minus 4 times 4 plus 3 gives me a 3. If I plug a 0 in, I get 3. And so lo and behold, and it's over 4 minus 0, I get an answer for this part that's 0. So the question is, when does the derivative, instantaneous rate of change, equal the average rate of change? And so there's my statement. Swing the 4 over, you know that x is going to be 2, and you're done. So just watch what they're asking you to set equal to one another. The next one I picked is number 11. This is a calculator problem. The temperature in degrees Fahrenheit T hours after 9 a.m. is approximated by this function. Find the average temperature during the time period from 9 to 9. Well, the average temperature is like the average y value kind of idea that we started out with. And so I'm doing this average rate of change. So I have 9 o'clock is the first hour going to 9 p.m. So it's a total of 12 hours that you've got going on. The integral is the integral going from 0 to 12, that 12-hour period, for the function 50 plus, now you could also said t of t, 14 sine of pi t over 12. Now they said it's a calculator question, so all you do is go to your calculator and you plug that integral in. And so, again, once you get the integral, don't forget you've got to multiply by 1/12 or divide by 12, however you want to look at that. And you end up with an answer that is 58.9126 degrees. So don't hesitate to use your calculator on those kind of things. And then I have one last one that I'm going to do with you, and it kind of summarizes the whole shebanga of this lesson. It is number 15, again a calculator question with trig. Glad I chose it. I have seen something like this on the exam several times, on the AP exam. There was a question about the produce aisle. I think it was bananas. That bananas were the store worker was putting bananas onto the display as people were taking them off of the display, and you had to figure out what that rate of change was and such. I also saw it as people going into an amusement park and coming out of an amusement park. So it's kind of very similar in idea to that. The traffic flow in this case is defined as a rate of change which cars pass through an intersection measured in cars per minute. The traffic flow at a particular intersection is modeled by this function, where f of t is measured in cars per minute and t is measured in minutes. What's the average value of the traffic flow over the time interval from 10 to 15 minutes? Indicate the units of measure. Now it specifically says average value. You're like, thank you very much. I know which one you mean. So it's going to be 1 over 15 minus 10 times the integral from 10 to 15 of your function. Do you need to write the whole function out? No. You can just call it f of t. All right, clean it up just a slight bit before you put it in the calculator. 15 minus 10 is 5. And so you've got 10 to 15 of your function, f of t dt. Hit the calculator. Figure out that integral for this guy right here. And then you are going to take it and multiply by 1/5, which is the same thing as dividing by 5. Don't forget to do that. 39.766. And that would be cars going through the intersection per minute. And then the last one says, what's the average rate of change? Rate of change. Now you're talking the Slopey formula. So I want to know what f of 15 minus f of 10 over 15 minus 10 is. And so I go to my calculator again, and I put this into my y1, and then I can set up a table so I can get the values. And it ends up that this comes out to be negative 1.518. But this one now, this was representative of cars per minute. But this is another set of minutes. So you end up with cars per minute squared. All right, that takes care of section 8.1. I will see you in class, but email me if you got any questions.